prove that anymore. Imagine what would happen with the erroneous logistic plan to make possible that this ultimate customer enjoy this product. So sometimes we're talking about 30%. 30% of the ultimate customers acquisition cost for the products. It's equivalent to the whole transportation system from the very beginning, from the raw material for the ultimate customer. So when we have here mobility, whatever technology that enhance efficiency in terms of mobility will impact significantly by far the competitive product offers and also the efficiency of the overall efficiency of the whole system. Modularization, we will see what is that, but in terms of the fourth industrial revolution is try to do things in parallel yet again to optimize efficiency. So this is not a secret from now on that the majority of the efforts counted on Industry 4.0 are totally addressed. Most of them, I would say over 90% of them are totally addressed to enhance the process efficiency in terms of time, in terms of human resources, in terms of especially human resources utilization, and of course material utilizations, time utilization, all this kind of efficiency metrics, right? Of course, when we saw that picture, we saw like a cloud warehousing, handling the whole data. So therefore, we need to socialize what we are doing for transparency. We need to socialize that to make a customer aware of our product, our services. And of course, there is one important touch, a special touch given by the fourth industrial revolution. We need to socialize and make that knowledgeable within the network, because the devices talk each other. They talk each other. So therefore, we need an efficient way to establish communication among the devices in order to enhance efficiency. So when you check these papers like this, taken from the International Journal of Production Economics, this is one of the most cited papers in this journal, which is very, very famous journal. So they said that you can contribute the market with a very competitive product and the very competitive product and the very smart product, what is called a smart product. If of course you made certain investment of your technological based, IoT, Internet of Things, your cloud, your big data, and your analytics. And in fact, this paper criticized that the greatest mistake, one of the greatest mistakes, especially for the small and medium companies, is that sometimes we deploy our greatest investment on this. Also, like our greatest investment on this. And the fewer investment is given on this. That's the major point of criticism when we check most of the serious literature, most distinguished literature in this field. And that's why today I'm going to show you as well that there are some examples where we don't deploy certain investments and we fell into, you know, what I call the new era of industrial revolution, but we don't squeeze really the greatest advantages of it. So of course, then if we got that solid, we can then offer smart manufacturing, we can contribute smart working, smart supply chain, and therefore we got a smart product, competitive product to serve the market, right? Let's talk about each of the pillars very tiny little examples. Why not to say? Well, we believe it or not, we are jumping every day to digitalization world, right? And in terms, as I mentioned before, we try to convert our physical material actions into intangible objects or elements managed by computers, aided by computers, right? So before we did it, I don't know, 10 years ago, most of us should print the boarding pass before getting to the plane. But now we just show it our cell phone and it's very secured. especially when we have charter places at the airport, right? We use in many cases of payment methods. So payments are the greatest example of, you know, avoiding physical for more security, avoiding physical actions in terms of payment. And this is something that reveals more intelligence, smarter way, right? So whenever we try to, for instance, book a flight, sometimes what we have is, if we regularly do this from the same computer, sometimes we see a kind of offers, a pattern of offers, right, to us. If this web page and the informatic system supporting that behind, um, it's include or it has some devices or some philosophy of programming or design based on the fourth industrial revolution. Of course, this is something most of the time done by artificial intelligence, and of course, it's a kind of pattern recognition. So we see a customer offering um, or frequently booking flights to South America. So therefore, whenever there is a chance, the customer experience is analyzed, and therefore, whenever you open a browser again to book flights, then you see certain offers very similar to your purchase pattern, right? Think what happened. A recent example of this. We are digitalizing experience. And still, for instance, in Spain, there is a combination of physical and digital actions. In Spain, I do believe that we need to pursue more for the digitalization of this situation, right? Like happening in South Korea, or like happening in, in, in also in Japan, um, and why not to say in other Asiatic countries that, you know, with certain permission and legal issues, then you could check the track, or if you are trying to visit certain place, so you know if infected people from um, coronavirus were you know, around there, and therefore give you certain alert about it. Still in Spain, we have like tracers, you know, we hire people, the government have been hiring people to, you know, investigate if certain people is infected, where the contacts. So, but still we can enhance the efficiency and effectiveness, why not to say, find the one who is infected and people around using this kind of technology, using the same infrastructure. The only difference is to find some people, smart people, who knows to program the algorithm to make that possible. So sometimes using the same infrastructure, the only difference is to invest more on knowledge. And this is one of the biggest mistakes of small and medium-sized company. I will jump this example very fast because this is, of course, this is very challenging from the engineering side, especially the 3D printers, manufacturing machineries. MIT had leading, and the lab has leading some research about it to make more accessible this kind of technologies to medium-sized companies, especially um, to make that affordable for medium-sized company. But of course, when you got, especially this video, you can check this video, and when you have uh, um, uh, companies, especially manufacturing companies, that, for instance, for you know, for the aircraft space, aerospace industry, when you got um, when you got pieces on the plane or something like that with very awkward designed interior design, very awkward, very hard to make it, and using the classic machinery. Of course, this is a wonderful technology to accomplish this kind of production in a very reduced time, even saving material, so you are not wasting material. And of course, this is somehow still not affordable for many of the company, but this is another pillar with autonomization that you have, you know, computers connected to these 3D printers, and they are performing this kind of difficult parts and components for tough productions line. Okay. This is a very trending topic, especially connected with transparency. Why? Because in the world, in the globalized world, we got a serious complex interactions among companies on upstream echelon, and we got also tough interconnections and the downstream echelon is in terms of supply chain networks. And transparency is tremendously important. So I will talking about this, but in principle, the blockchain technology or philosophy or paradigms, let's talk about this. Try to somehow exclude the middleman, the traditional, this all start trying to exclude the middleman in the financial transactions. And traditionally there was a bank, for instance, especially international logistics. You got a one person who is producing something and wants to deliver to the customers. Traditionally, export management or export activities, people try to protect both sides, trying to protect themselves with the financial institution to play a certain role, like, you know, like a trustworthy man in the middle. Nowadays, what we have is that based on this blockchain platform or blockchain paradigm and philosophy of distributed system or distributed ledger for the accounting and the financial flow optimization, then what we have is faster payment method, and information can be in principle adulterated because you got de-aggregated in blocks the information or those blocks that form the whole code of information, and it's very hard, or I would say it's harder to that the information could be adulterated. So we will talk about that later, but certainly transparency is very important, especially in this blockchain part. The part I like most is the something what is connected with the smart contracts. Smart contracts. We'll talk about that later. Mobility, of course. Especially in the complex production lines, we need to know where exactly the product is. Even using the code, the traditional barcode, what we have is that we, of course, less efficient, but still this is a solution for a small and medium-sized company. So what we have is that, especially something like producing a Boeing, for instance, whatever kind of Boeing, sometimes you got millions of components to produce or perform one plane. So of course, think about what happened. The other day, I was checking the price of the turbine for the Boeing, especially the 747, and it costs over 20 million euros. It costs that. So imagine what would happen if you, I don't know, as a stock, you got 2 engines and the warehouse and the Boeing warehouse. So the daily operational cost of that, or the holding cost of the inventory, is huge for the company, and make very less affordable Boeing for the customer, and made that very less affordable for whatever to want to book a flight. Okay, so that's why Boeing system is almost just in time. But imagine for having just in time this engine, this turbine of 20 millions for the 747. Therefore, you need to know what it is. You need to know the actual online information. You need to know what it is in order to compute how long does it take to come here, or how long does it take, including certain failures to be added to the production line. So therefore, in terms of, we're talking about logistics, this here has one of the greatest impact, especially many kind of classical industry, tremendous good impact in terms of saving money for the holding cost of the inventory. Of course, you could also cut man hours because you don't need demands at certain times, because you know it will take longer and you got updated information. And of course, more efficient component deliveries, as I mentioned before. And also you even could optimize better your inventory, especially your safety stock. Okay. Even, you know, more secure for the component transportation as well. So of course, whatever kind of investment you are fully dedicated to this kind of mobility, of course, you need to think about that. This example is evident when we're talking about very expensive components. Okay, sometimes I had checked doing in my previous work, doing certain consultancy. You see that people wants to add RFID to whatever kind of product they have, and sometimes the RFID somehow an important part of the product cost. So it doesn't make any good to do that because, well, we are on the age of the fourth revolution, industrial revolution, so therefore we need to be insert on that. So it doesn't mean any good to do that if there's no certain relevancy on the product cost side. Okay. As I mentioned before, these two, autonomization and modularization, I would say that those are the more challenging from the engineering perspective. Okay, especially for instance, designing a machine like this one, where you in parallel could, for instance, this is a 5-axis machinery center, and designing a machine like that, where you in parallel could accomplish multiple functions, like, you know, processing pieces and this kind of things, is very challenging. Of course, you want to have in your production workshop, you want to have machinery like that, where you can parallel and, of course, make a great reduction of the processing time. This is tremendously important. Why? Because if you don't have to unplug your production and then plug that in again and substitute that when you got a production in batches or a lot size, right? And then you spend a lot of time setting the machine, preparing the machine. So therefore, when you got this kind of modularized machinery, of course, you save a lot in terms of reducing the setup time. And certainly this will all you produce in the same period of time, you will produce more items. So therefore your productivity increase. So if you ask me, these two are very hard to address, especially if you are managing a medium and small size company. But the others are doable, are affordable. I will tell you why. So, and as I mentioned before, we're talking about let's say IoT, and the IoT environment is there's enormous importance when we're talking about the network collaboration and we socializing products and process. Think about it. This comes from the very famous German Research Institute. I got my degree there, and as you can see, for instance, that's what the logistics 4.0, because we don't have so many manufacturing processes here. That's why Industry 4.0 both focus on both. But think about it. I was reading the other day a paper that people said that in terms of productions like this and this, fewer things can be done. Still, things can be done, but enhancement can be done. But these are the part with the greatest chances, I would call the niche for improvements. Okay, so we're talking about people with efficient connection and a clear customer profile defined by these wonderful devices. Their needs are transported at different layers of the supply chain, at different tiers of the supply chains, right? And there they even could track, everybody can track and exchange this information with the cloud of the product, managing and optimizing part of the process. But at the end, the customer will have a smart product where everything is autonomous. That's the idea. Of course, you can't do that if you don't work on the core issues. And this is, as I mentioned before, this is the greatest problem here. We got small and medium sized companies investing on the devices that primarily have the function of what? Measuring the data, warehousing the data with great capacity, manipulating the data, good term, I say data handling, transmission, or whatever it is. But we had very reduced investment on what? On processing data. Not for whatever aims, for the most important aim, which is enhancing the efficiency of the system. And that's why we repeatedly hear terms like this system, what it has behind is artificial intelligence. This system is had behind a big data, data mining algorithm um, to decide things, to even think, okay? So, and this comes a great confusion. So in principle, this artificial intelligence that people sometimes confuse as even with science fiction movie. So we're talking about computers capable to learn from the process, okay? Learn in the way because we feed that with data, make decisions. With what purpose alone? Aim the process efficiency in terms of human resources, in terms of financial resources, in terms of the time consumption, and in terms of material resources. Of course, for that, what we need is data, we need experience. And that's where the companies sometimes fail because the huge investment is here to collect this, but a very reduced investment on this, algorithm and human instructions. People who knows algorithm, people who blame that on the computers. So, and people confuse that. People think that the greater is, or the massive is my data set or the experience I collect and translate from the process historically, then I will have greater chances to improve my process. This is wrong. This is wrong if we don't translate data into information and then finally into knowledge. Of course, here data is basically what we have is we got, you know, a matrix, I don't know, full of zeros and one, meaning that zero, this guy bought the product day Friday, okay? But now we put that in context, which is called information. And the most important part is if we discover patterns, if we discover rules to interpret that data or to translate that interpretation into process efficiency. That's the whole idea. For instance, as I mentioned before, the example of the regular patterns. So we know people are booking flights from certain IP number of certain computer. So therefore, we see a regular pattern that this person every Friday is buying a flight ticket, or every summer is increasing his purchase pattern or his purchase rate. So therefore, why to give the discount during that? If anyway he will buy it. Okay, probably we need to give better the discount in another period of time. So sometimes we call that artificial intelligence, but what we have sometimes behind that is some classical statistics algorithm or a statistical test, and we program that in a very efficient languages, and that is called artificial intelligence. Okay. Well, I will jump this. Sorry, I will jump this here. Of course, this is important. I'm not saying, or I'm not underestimating the part of measuring efficiently data or having an important network digital system. I'm not saying that. What I'm saying is that this part sometimes is totally disregarded, and this part as well, which is called not only the data security, also the transparency of that. As I mentioned before, what we have is, in the case of blockchain, we have the information transferred, or the information flow among the elements or the organizations of the supply chain. So sometimes these kind of transactions are saved in a unique computer or in a unique is taken care by a unique institution or firm. So in principle, the philosophy of the blockchain is that we aggregate that in blocks, right? There are multiple platforms based on blockchain. There are multiple communication platforms based on blockchain. What I'm explaining here is the philosophy behind these various platforms. So the idea is to de-aggregate that, decentralize that in kind of blocks, and like contrary to what we did before on the banks, that all the financial information goes to this financial institution intermediary of the operations. So in terms of doing that, we decentralize that on the network. We decentralize on the network, and this network, each node of this network, it has certain blocks. I mean, somebody try to read that blocks, they can't understand what is that, what kind of information is that. You need to unify all this block, decentralized block, into a chain of blocks, and then of course that's the way you interpret that. But if somebody wants to penetrate one of these blocks, then the whole system is notified. For instance, this happened uh, um, traditionally like that. Of course, as I said before, this, because you are taking away the middleman, especially this all start in the financial transactions between suppliers and customers, right? If you somehow try to exclude from that system or from that network, if you try to exclude the traditional financial institution, the fees are very low compared, I don't know, to Bitcoin or cryptocurrencies fee, that traditionally what you have is lower fee for doing that kind of transactions. It's supposed to be by far much more secured compared to the traditional financial system. So the whole origin of this wonderful philosophy, translated later in multiple various platforms, use it now globally, is that we deaggregate the information. It's like a digital ledger, deaggregated, decentralized it in multiple places, like called blocks, and then and this is harder to adulterate. That's the idea. I bring in here a little story about this. As I said before, this all started with digital payment systems, and well, people now are very tender to use 1.0, 2.0, 4.0. So now we're at the age of 4.0 for multiple things. Um, and the later from 2004, this all jumped to something which is wonderful, which is called the smart contracts. A good example of that, I was reading the other day, is given by YouTube. Is that YouTube, for instance, is using blockchain, and of course I blame it in artificial intelligence, which is the current situation or the current usability of blockchain. So combine this secure way of data spread or transmission with artificial intelligence to process that, to understand better that. And a good example was that at first YouTube had faced certain problems with loyalties, with loyalties, um, and you never know who was owning the intellectual property, and why not to say also the rights to certain music or video, or I don't know, uh, some video material, for instance, let's say some media material, right? So and it's very hard to distribute the money. Normally what has happened is that companies paid to promote their products there, like sponsors, right? And this all volume of money is taken by YouTube. And how do you distribute that even or fairly, like a fairness profit distribution, right? Based on, you know, who posts certain videos first, based on all kind of features that describe um, most impacting video. So of course, sometimes this kind of information could be adulterated. And this is a typical example of a smart contract. Like smart means that it's fair. Smart means that no matter what happens, you receive the money for what you give, right? And in that kind of environment, in the fair way. and there's a very fair money profit distribution based on the, for instance, in that case, the higher impact in media, for instance. Imagine then the number of elements that describe the impact of certain video or certain media material on YouTube, for instance. There are so many indicators that describe that. And you got a lot of users posting. You got a lot of users uploading videos on YouTube. So this is very hard if you don't have secure system to hold to warehouse the information. And also, most importantly, here is some artificial intelligence algorithm platforms to process that and, for instance, make the actions that we are waiting, a fair distribution of the profits. So that happened also for, you know, a construction company. Imagine that construction company, you have, I don't know, a lot of suppliers because you need a lot of items, and for each item you have a lot of suppliers. You got a huge list of suppliers, great list of suppliers. Okay, so therefore you need that. You need something that keep your information safer, and why not something that simultaneously process that information with the whole aim to enhance the process efficiency. I'm collecting here some statistics from the last year. There was a very interesting survey published by this author, and if you see here, what you can see is that a blockchain is still in the because I think this was yes or no, so that's why you don't have a complementary value of 100 here. But what you see is that majority of the usability is given in the supply chain environment, IoT as well, meaning that the information, you know, shipped among the devices should be transferred in a secure way, and also the interaction, meaning that the financial interaction, why not the information interaction, not only financial information, about the elements of the supply chain network are using frequently the paradigm and the various platforms of blockchain. Of course, this is not a surprise for me that suppliers are using most, you know, blockchain, because you got a lot of customers, for instance, and they are using, those are the stakeholders, the shared stakeholders that are more connected, are more related with that blockchains. Almost evenly distributed, these numbers, almost 50-50, you know, from the list of surveyed people. And of course, what is the greatest features everybody is pursuing is the speed, the efficiency of the systems compared to the traditional, especially because still the financial sector is the one who is using most this. So if you see that you know, if you somehow beat the traditional system in terms of the efficiency of money transfer, and why not to say avoiding high fee from the traditional banking system, so therefore people will do appreciate this kind of features from the blockchain technology. In the pharmaceutical sector and the clinical healthcare system, also I would say, especially in Switzerland and United States, this kind of revolutionary changes, what I call, for product traceability and for also product recall, it's highly usable. Um, for instance, there are serious technical magazines talking about how Walmart, especially Walmart, and was facing some problems with the perishable food, and also the adulterations on the data. I think was not on purpose, but it happens. So therefore, if you know if you got a wonderful device, like RFID telling you where the product is exactly now, but if this information sent to the cloud could be adulterated or could even uh, have certain inconsistency, then if you got if you implement this system to make that unadulterable and also unaccessible from hackers or something like that. So therefore you can trust that when the system or there is a artificial intelligence system program to identify when exactly the problem should be recalled, then you know exactly that you can trust on that. So you don't only have a wonderful algorithm program to classify that product in the non-usable product anymore. You also can trust that the way you feed that algorithm with the data you feed the algorithms are trustworthy, and um, of course you measure that with a efficiency with a very good device, a reliable device, and the data transmission have been done through the platform, very reliable platform as well. That's the whole idea. Well, of course, especially in what is called smart warehouses, and I'm going to give you an example here, how the sharing economy as well had been producing. I don't know if you go now to whatever important conference in the operation research um, world, everybody's talking about sharing economy. Sharing economy is a booming topic among the scientific community. Why? Because especially now within the COVID, we need to be much more efficient in terms of the resource utilization. And still, the statistics are very shocking in the way of saying that we have a global fleet of big vehicles used, I don't know, sometimes if we are lucky enough, at the 75%. This is utilization level. So there's still minimum 25% of the transportation system in the world that we are using that is totally idle, totally unutilized. So the sharing economy, for instance, in the area I work very intensively, which is transportation or transport optimization, uh, we need we need we need to measure actual information about, for instance, I don't know, we got a truck empty coming from Hamburg to to Potsdam in Germany, but we need to know that this information is reliable because we got a, I don't know, we got a system um, with the blockchain platform and artificial intelligence to process the information, and we certainly know that this system, this phenomena is measured online, and this information is placed on the reliable environment, which is somehow defined by blockchain. Okay. So sharing economy, I mean, all these technologies are impacting positively, significantly, the sharing economy, which is a booming topic, not only because, well, this is something new and we want to investigate, we want to do research about that. No, it's because resource optimization have been will be always for the mankind, will be always the right path, the right path. Like the same importance like innovation. So we are creating something new in terms of a big business model, in terms of a product, in terms of a very innovative engineering device. This is important, but also using the thing that we are already created, and therefore using that also help us to enhance um, um, efficiency. Yesterday we had a PhD defense that I was supervising at our center, and our PhD students had a wonderful topic about exploring more innovation versus exploiting the design innovations. So what is the right, what is the right trade-off on that? Because innovation costs money. Okay, so therefore we need to be careful about the way we manage that, right? So this help a lot, especially in the sharing economies environment. Think about it. This is a picture This is a picture of this is a picture of I would say the smart warehouse. This is a real setting from the pharmaceutical industry. I cannot reveal the name, of course, for confidentiality issues, but this is something like that. So we got, think about it. This is the clear pictures of IoT and Industry 4.0 that we got here, a kind of warehouse already insert and this era of Industry 4.0. So we got wonderful device measuring temperatures, humidity, vibrations, all these kind of parameters that are strongly connected with what the good conservation, the good keeping of our products. So this all is read by these wonderful devices, high tech for that, and then you read that and you store that and you also send that through the blockchain platform. Okay, then of course what we have here is we got if somebody wants to adulterate that, because we got a network of users having access to different blocks, then if there are certain parameters deviation, then we see that somebody's trying to adulterate that. So especially in the pharmaceutical industry, stealing the intellectual property is a serious issue, and it leads to those kind of industry to billions of losses every year, you know. So imagine that we have that in a very secure environment, all these warehouse parameters read, right? So then we got here algorithm. Still, we can't escape from this equation. We can't escape algorithm, mathematics, tough things, and not scientists, top professionals implemented that artificial intelligence, because why? We need to address a massive volume of data, right? And then what we discover is based on, I don't know, knowledge discovering algorithm, classification methods, forecasting, whatever it is, then all kind of algorithms already implemented here on certain devices, then they discovered that these parameters are suffering certain deviation from the, I don't know, kind of quality standard, right? So therefore, even the same device could give the orders to these devices or to other devices, especially to other devices. I don't know, they calibrate the climate, I mean the air conditioner within this warehouse, or the humidor, for instance, within the warehouse. So multiple devices that somehow control those parameters. So these data processors of the inference system, the brain of the system, could give directly the instructions to those devices, like the automatic air conditions, or numeric control air conditions, or the humidor, for instance. So these devices check or enhance the conditions or recalibrate the conditions of the warehouse. Sometimes if the conditions were good and instead you can say, okay, I could extend the life of this product. So directly this gives the structure to this RFID or whatever part of the product. Okay, you can extend the use by date of that, or you can even declare the product unfit because suffered certain deviate conditions of the warehouse, of the parameters of the warehouse, or even apply some penalties. For instance, in a warehouse like a grocery place, you can say, okay, these could suffer certain price discount as well. Of course, if you see here, we don't see any human, unless the humans that, you know, program all these devices for the preference, for the first functionalities within the warehouse. That's the whole idea of the Internet of Things. Still, on some places, you can avoid the human intervention. Sometimes this is read by humans, and for professionals that they directly in person, I mean, the physical actions can be are still inevitable within the warehouse. But this is the idea. Try to skip the human action, because humans could interpret that in an erroneous way. So therefore, we somehow diminish the number of failures, and also we do that very efficiently in terms of the money spent, human resources spent. Of course, this comes with an important derived question, which is, so where we employ people who are, you know, somehow dismissed, because it seems that we need fewer number of sorry, fewer number of persons and better educated. This is not your case because you are taking this wonderful education, right? But so people might say, okay, what is that? So if you recall the innovations, sometimes there are other pillars that could, the idea is, I was hearing a Nobel laureate talking about that. And this guy was saying, okay, this industry 4.0 could impact negatively the job creation as a macroeconomic aspect. But I hope that after reading some of these pillars, we certainly will have job creation on other of the pillars. Okay, so especially creating more services, so servitization of the, because industry 4.0 also claim for greater servitization of whatever it can derive from certain services, then there will be human innovation on that, and therefore we create jobs. We save job fears, but we create more services and a more customized way to address the customers. So therefore, we will create somehow a cycle, a life cycle, saying in some cases we lost jobs, but in some cases we increased the number of jobs. I would like to finish because I think we are close to 1 hour here, right? I would like to finish with one wonderful technology inside the warehouses, the autonomous vehicles. And I would like to show you the evolution when there was not even established the name of Industry 4.0. And think about it. I think this summarizes somehow the evolution of using correctly the technological advances with the classical algorithm and mathematical and computer development all together to have a device and a smart device. That's the idea. So those autonomous vehicles, of course, they held the materials within the warehouse without being guided by humans, right? That's the idea. In fact, when you check some famous companies providing this kind of autonomous vehicles, the very first time I saw that was in 2008 when I went to Germany, when I started my PhD, and I saw that. And in fact, my PhD was about to design algorithm based on artificial intelligence to address complex optimization problems. And one of these optimization problems we will see here, like the traffic inside the warehouse, is very tough. And the fleet optimization is a very tough optimization problem. And imagine that at those times, of course, I never thought that some algorithms that I designed and I also programmed, some of those algorithms could be used later, or variant of those algorithms could be used later inside, like a small brain inside of this, to optimize traffic or to optimize, you know, the operations inside the warehouse. The good point here is that you even see sometimes providers, these device providers, even giving you the return, the period, the return time, or uh, the RIO, sorry, the ROI, which is return of investment period, giving that, saying, okay, if this traditionally for the customers, we already offered that, they traditionally recover the investment on the device between 1 and 2 years, which is something very profitable. I mean, because you already had that, and this doesn't get old that sooner, you know. The very first one were very, you know, primitive. Now we see that primitive. The first navigation system was a magnetic tape, and of course was never drive by any person, any operator, but they got a kind of fixed path within the warehouse. And of course, this is very, very inefficient. Imagine that you got, I don't know, millions of items within your warehouse, and sometimes you make a mistake and then you need to go back, and probably you don't have the possibility to define all possible path within the warehouse with it. So it was very expensive, but at those times it still aims for possible efficiency. Later, of course, this was never guided again by the fixed path or the magnetic fix. So we got a laser. Basically, the laser navigation systems try to, you know, to give more freedom in terms of the path that should be taken. But of course, it was very secure in terms, well, no, avoiding crashes within the warehouse. And this is the most important part, which is called the natural navigation system. And this is where I somehow, I think I saw that in some journals, how natural inspiration for optimizations were included and blamed into these navigation systems in terms of optimizing the traffic inside the warehouse. Why not? They even, what is called fleet optimization, the meaning of that is that when they fear that there's not sufficient work to do, they even go to the kind of parking place inside the warehouse, and somehow we got a smaller fleet because at this point we have a report, probably recorded by the RFID, probably the information was sent using the blockchain platforms, and then this information is given to the brain of this smart vehicle, autonomous vehicle, and there's an algorithm inside that the algorithm tells, okay, this autonomous vehicle should go to the parking place. Why? Because it's not needed. There's not sufficient activity. And for, I don't know, for the fleet side of 7 vehicles only, instead of 9 or 10 vehicles, autonomous vehicles, then the whole activities of the whole assignments can be done. So to finish my presentations, I would like to, let's see if this video can be presented. Can you hear now? Can you?
No, I don't think so. Is it? Is it playing? It doesn't look like it is playing.
The video is not playing.
Are you here?
It's playing.
Can be heard?
No.
No?
No, Jessel.
Oh Lord, that's a pity. I don't know why.
Try play it.
Try play it now. Just give me a minute. Probably blow. Ah, here it is. Lord, you see, you learn every single day something. Now, yes. Yes.
Play.
Can you hear it?
Try a little bit higher, just in case.
Can be heard?
No.
No.
Just share it with me. I will get it to the participants, I think.
Okay. Blog, but I allow videos, so I gave everything. Let me check. Let me try on another browser. Just 1 minute. It's 2 minutes only. Can you hear now?
Really low.
No?
Very low.
Very low. Okay. Let me check here. Well, it is okay?
Very low. We can hear some people talking, but we can't tell what they are saying.
Yeah.
Okay. Then this is a pity. I mean, the link is there, so you can check that. The idea is, let me. This is the idea. Can you see the screen?
Yes.
Yeah.
So the Cole Morgan is a very famous company that they offer you could see the evolution of what I had present. Like, you know, at first, the autonomous vehicles were very, very myopic, I will say, you know. But now what they're proposing is that there is a kind of course, of brain, and there's a centralized called like decision center, right? And this optimize the traffic inside. And this is not important only for the collisions among the items. No. It's optimize the traffic, you know, like taking the shorter path, no crossovers among the vehicles, so they saving the time and spend and all the stuff. And also the autonomous vehicle fleet. That's important. So I encourage you to watch this video. It's very important, and you will realize that it's not about only the technology. Just buy a fancy device. It's also invest on the knowledge to manage that, on the knowledge to squeeze that technology in terms of process efficiency. Okay, having said all that, I would like to finish with this, and thank you very much. And the questions are welcome, please.
Thank you very much, Yasel. I think we have just a question here on the Q&A. So the question is from an anonymous attendee. What is your opinion? What, in your opinion, do you think is the position of this supply chain profession or professionals in the light of emerging digital era of e-sourcing, e-logistics, and the fourth industrial revolution?
What is the position of, sorry, say that again?
What is your opinion, or what, in your opinion, do you think is the position of the supply chain profession in the light of this fourth industrial revolution?
Well, maybe my opinion is a bit biased, right? I will try to be very objective. This is a very tough question. If you ask me now, supply chain professionals and planners, if they are good professionals, they are traditionally manage somehow multidisciplinary abilities, you know, multidisciplinary skills. Like, for instance, they got like qualitative or theoretical management abilities, like, you know, decision science abilities. But many of them, I would say the majority of them, data analytics. They address a lot of, you know, problems concerning data analytics. So if you ask me, this exactly goes against the point of criticism that we have, or the classical mistakes that small and medium companies fall into. That they invest a lot on sensors, they invest a lot on servers. You had companies investing on SAP, for instance. It's very expensive, SAP, especially financial modules. It's a kind of ERP, right? And sometimes they invest very few on professionals like supply chain planners, knowing forecasting algorithm, knowing, for instance, multiple methods, and knowing how to implement that. Like, for instance, my student from MIT Scale, if you check the thesis they had and the way they managed that, they now are inserted in the Industry 4.0. Why? Because, for instance, one of my supervised students, they programmed something to optimize inventory for a clinical healthcare industry. But they also programmed something to have a dashboard from the cell phone as well for the planners. You see that? So they close the whole loop. They know the theory about how to optimize better the inventory in terms of the current situation of the company. They know how to digitalize that as well, you know? So of course, I think it's a crucial. I think I do believe that even the employment rate, for instance, you could check the employment rate of our CERN is over 90%. And this is not because only the name of the MIT, it's because the abilities they have. It's because the abilities they have. And now if you ask me what they need to do, if you are a professional who is capable to do all the stuff I mentioned, what you need to do is to try to understand better how to digitalize that in an efficient way, how to socialize that in an efficient way. That's the thing. But if you ask me to summarize, my whole answer is I do believe this will be highly demanded professional in this new era. And a very recent survey tell me that. I worked with a professor from North Texas, and think about it. A supply chain professional, this survey tells us that a supply chain professional, different from previous time, is now the second best high employed in the whole United States. After, you know who is the first one? The first one are the guys working for, you know, in the financial sector. Still Wall Street, you know, well, sorry, Still Wall Street is promoting a lot that, you know, and those are, if I was checking that, those are the more employed guys. We need more jobs in terms of supply chain professional, and they are the second best paid. That's what tells me. Very recently, I had a discussion a month ago about this. So that's my opinion.
Okay, great. So we have a question from Rakam saying, and I'm going to combine a couple of questions, saying that the future is digitization and modern technology, blockchain and automation. In developing countries, this will be very expensive, but ideal. What is the way forward for small and medium enterprises? And I'm going to combine that a question. Yeah. I'm just going to add one more question so that you can answer both. So the other question, which has probably been asked by 3 people, is that as a supply chain professional, do we need to be IT experts to better understand these technologies and better position ourselves? So do we need to develop some IT skills? So that question has come in from probably 3 or so people.
Excellent questions. I mean, those are very tough questions, and of course, this is the core. Those are the core issue. Referring to the first one, yes, it's true. It is evident that this is highly useful and easily to adopt for companies with excellent financial health, of course. But again, this is about that's why my presentation, and that's why I've been checking about the statistics of the other scientists from the community. For instance, think about it. You could, this is a typical example of Industry 4.0 environment. You have a grocery, you got a grocery with a barcode. You check in your products, right? Imagine that you want to optimize your price policy, and you want to optimize the position of your merchandise. So you have in a computer, using the same devices, you got in your computer that the customer I bought different items, 0 or 1, 0 or 1, 0, 1, different items. So you got the list of items per columns, and you got customer per rows, right? This all is saved in a computer, I would say not a expensive one, not a high performance computer. And then you got an expert programming association rules, which is an artificial intelligence data mining algorithm, let's say. It's a kind of approach, right? And then what you discover is that every Friday, majority of people are men, and they buy beer and milk simultaneously. So why you should place the milk and the beer so far from each other? If you want to optimize the customer experience within the warehouse, that's it. You do it, you place it, you know, you discover the pattern of purchases. And also what you should give discount to both products if they're gonna buy it anyway, with high probability, okay? So I will play this example. Barcode is accessible in the developing countries. The computer for warehousing this data, derive this data is affordable. Probably you can afford blockchain platform because it doesn't make any good for that kind of problem. The money you're gonna save with this doesn't cover that technology. But you are using part of this environment of Industry 4.0. You got devices measuring the data. The very first investment you should do is on what? On that specialist that is capable with a small computer, no high processing computer, to implement or to program the association rules, this data mining algorithm, for instance. Okay? That's a big problem. People start investing more on what? On an RFID to collect more reliable information of that problem, a blockchain to transmit the data for data transmission, a high performance computer to warehouse the data, and then at the end, there is a lack of money to hire someone to take care of that. So my advice is, when the circumstances permit it, the very first investment is not on the technology, it's on the people who knows to manage the technology and utilize better the installed capacity. Okay? That's the idea. Referring to the second one, which was about if you require certain IT skills. Well, I mean, this goes for whatever kind of profession, right? In my profession, of course, if you ask me, what we ask here at ZLC, if you check, for instance, we educate professionals at the very top level. Not because it's the name of MIT behind, no, sir. It's because certainly we try to reinforce abilities like that, you know, abilities like we have students that they know how to I don't know, they know 13 models to do a forecast, which is the very first thing that should enable us to enhance the process efficiency. We know we have this, we teach the student to learn 13 models, 10 model of forecasting, but we also teach them how to program that at least in Excel or I don't know, in Python as well, or on R, for instance. So yes, of course, it's like a professional who doesn't know English. He's very good in mathematics, but he doesn't know how to explain that. So IT is a language. Computer science is a language. It's a language of computers. So if you ask me, you shouldn't be the specialist who knows, I don't know, 10 kind of programming languages, you know? You don't have to be a guy who knows, I don't know, 10 kind of platforms of blockchains. But something is important. Of course, you could be part of a team, as a multidisciplinary team, who is the guy who gives the algorithm to a programmer, for instance, of course. But of course, in the small, medium company, we probably will need a guy who is capable to do both things, you know? A guy who's capable to know about the algorithms, to know the solid mathematical point behind that, and the guy who knows to implement. And probably in those kind of countries, we need to be honest. We need to be honest. In this kind of developing countries, we can afford easily this kind of people, you know? That's why, I don't know, when I was working in Austria, we got a lot of people from India working for us, even people from South Africa and from Nigeria as well. We get people from many places from Africa, highly educated people, and they like to come to, for instance, to Austria because, of course, better paid, you know? In developing country, we need to, if we invest more on those people, they want to stay there. Instead of investing more on technologies directly, no, we need to invest more on squeezing the installed capacity. That's the idea. So if you ask me, yes, would be good if not especially in IT per se, but a person who is capable to communicate and to understand the logic of the required skills of IT behind that. That would be better.
Okay, great. So as we as we go to the last two questions, I will try to combine even with a small third one. So there's a question from Kenneth Sang, who is doing his Master's of Science in Supply Chain Management, and is asking what are some of the research gaps in the area, and what does he need to do more for his research. Then we have a question from Mohammed Afin, who is asking, where is the main playground of the telecommunication mobile operators in the AI big data mining field, and how can both be linked to each other? And I think I'll finish with the last question, which is probably related to what you've answered from, I can only see the name as MM, asking, or do we need to pursue more of data analytics?
Yeah. I think the first one, sorry, remind me again the first one, because
the first one is Kenneth doing an MSc in supply chain, and he's just asking what are some of the research gaps in the field.
Okay.
Yes.
Okay, let's finish this one. Research gap in the field, of course. Still, there is a big problem, especially in AI. AI, what you have is still the information is huge. There are massive data set, and especially in the operational decisions, the research gap is, believe it or not, we need to process the data, we need to optimize the system in sooner time. So still the research gaps are to the computational complexity of the problems and the algorithms that address that. That's the big problem still. That there are a lot of research gaps on that way. Of course, those research gaps are mostly covered by academics, with solid background in computer science and mathematics, you know, to designing an algorithm with that address complex problems in you know, very efficiently in terms of consumption, time consumption, you know. That's the idea. That's still in fact, is one of the 7 mathematical problems of the century. One of the 7 mathematical problems of the previous century. I think every century will have the same problem to address this kind of non-polynomial bounded problems, which are very complex problems in polynomial times bounded. So that's still a research gap. And of course, in practical terms, another research gap are very focused, very connected with the questions you had made, the wonderful questions you had made. How to make the technologies accessible, reachable, affordable. And that's what I mentioned about MIT. MIT has a wonderful lab there is a huge budget fully dedicated to make 3D printers in whatever kind of manufacturing process, make it more affordable for people and accessible technology for people. So this is a huge research gap nowadays. Make affordable the technologies framed in these for industrial revolution. That's I would say the biggest one of the biggest one. Okay. The second one, you're talking about telecommunications. How, remind me again that?
So the main playground for the telecommunication mobile operators in the AI and big data, and how both can be linked to each other.
Well, this is somehow far from my expertise area. I should be totally honest here. But as I said before, the logic way I see that connected is that, again, artificial intelligence, as I always like to mention, is not a science fiction stuff. What you have there is mathematics, statistics behind that, pure mathematics and statistics, even algorithms from 400 years ago, like, you know, classification problems, forecasting problems, regression analysis, association rules, principal component analysis, those kind of things, optimization techniques based on partial derivatives, things like that. Of course, the thing of artificial intelligence, I don't know, for instance, you could solve problems like that with the absolute optimums, like, for instance, transportation problems, like I did during my PhD. But for instance, in the artificial intelligence in my PhD, what was it? I studied the behavior of the ants that traditionally find the shorter path between the nest and the food sources. They traditionally try to find through the pheromone communication, they traditionally find the shorter path. So I translate that. I mean, there was a guy who did it first, but I did a very best variant, a better variant for that, and I demonstrated that. What I did, I translate this natural behavior into algorithm. That's very tough probability calculations and this stuff to solve network problems. You know, many of the logistic problems and even the telecommunication problems could be translated into networks problems. Okay, so once you translate that problem into that, I use natural inspiration, which is called artificial intelligence, to solve large scales instances of that problems to reduce time. Imagine you need to dispatch vehicles. So this is an operative decision. So you need to make the decision just like that. So you cannot, sometimes you sacrifice the optimum travel time or the optimal fuel consumption, because in terms of sacrifice, that you get a bit less, but you solve the problem faster. So that's a typical connection of the, you know, the mobile, for instance, that generates a lot of data, and then the way you connect with that, with artificial intelligence. So artificial intelligence, you just need to see that's the brain of that. There are the algorithms, the instruction given by the humans, and of course, the big mistake is to invest a lot of the infrastructure for data recording and data transmission, and investing very few on the brain of that, which is people, smart people, programming, working, squeezing the technology, utilizing as greatest as possible. And the third one, what was it? The third one?
The third one is I'm going to have it as a part of our closing remarks, because it is a part of what I was thinking, as what I will request you to share with the professionals on this forum today, which is what as the supply chain, logistics, purchasing, procurement, warehousing, and all everybody involved in the supply chain, professionals, what do they need to do, especially in our continent, Africa, to be one amongst the highest paid, just like in the US, like I've said, and second, to be ready for the future, to remain and grow in demand as professionals, and use these technologies to position themselves to impact the nation and their companies that they work for. And then as you answer that, you will also give us your closing remarks, and then I will close the forum.
Okay, good question. I mean, what should be done? Of course, if you ask me, everybody could use, most of the people could use a cell phone. Most of the people, the technologies had been made accessible for people for that reason, because people should pay for it, should use for it, and then therefore, but a few people know how that works behind, how it works behind, at least had the intuition how it works behind. So I see sometimes the students waste an excellent opportunity, or professionals sometimes waste an excellent opportunity to learn the classic things, the classic approach, like for instance, the example I gave you in the forecasting methods, you know, to learn how the mathematics, a few about the mathematics of the forecasting methods, how some technologies that had implemented that, you know. Sometimes people, you know, it says, take the data here, you take the data from the Excel, click on this button, these are the outcomes, and even you got a manual to understand that outcomes. But imagine that you know somehow the algorithms behind that, so then you can modify and adapt those algorithms to your new company or to your new endeavor, you know. So imagine you can do that. You will be a very competitive professional if you are capable to do that. How could you do that? Well, again, everybody's starting something that the basement of that people sometimes underestimate. So I mean, my suggestion is, my student did appreciate that. Every year I teach that, because they know for instance, Python is, as a programming language, is simpler compared to C++, for instance. When I did my PhD, I used C++ or Java, for instance, to program that, my algorithm and this stuff. I saw Python as it's very friendly. They got a lot of things already integrated. But again, so people get used to easier with programming language. But again, the mathematics and the structure and the logic of the problem solution, they are now underestimating that. So my suggestion is start doing that with the classical approaches, and then why not, again, try to, somehow use technology for enhancing the efficiency on that. But you shouldn't take out of the equation the understanding of what is behind. That's what I'm saying, okay? And again, as a closing remark, what I want to say is, please, especially in Africa, like South America, this is not far from the example of South America. Me as a Cuban, I also visit a lot of Colombia and Mexico and South American countries, Central American countries, where they want to be inserted on this because they know that the money is there and they want to be competitive. So please do not commit the sin to dedicate the greatest mental, cognitive, and financial efforts to the technology per se. Dedicate more to squeeze the actual technology. And you need to hire, and you need, if you are a manager, you need to hire knowledgeable people. If you are the ones to be acting at this post, acquire the abilities, like I told you, what is behind, you know? If we're talking about, most of these are based on statistics, mathematics, you know, and day by day, we got more friendly technologies to translate that things to the computers. So I'm very skeptical when I see people, you know, investing time, so much time on, you know, on be updated, totally updated concerning the technology in terms of, you know, understanding how to solve the problem and then how to translate it with the current technology you have, the actual investment you have on technologies, you know. That's my closing remark. So the greatest investment should go to what is behind, to knowledgeable people and to acquire those kind of skills. Okay, that's the idea.
So thank you very much. Thank you very much, Doctor, for this wonderful session. I know we have stayed for a while, but it was important. This is what the future is. What I picked from the session, especially your last remarks, is let us know what is behind the solution, the problem. So I'm picking up simply the Excel sheets that we use even for planning, whether it's spend analytics, whether it's MRP, whether it's demand forecasting or supply planning or production planning or even budgeting. In supply chain, some of us use a lot of Excel sheets where we don't have systems, but even that, we still don't get what is behind, what are we solving, what is, because it's almost like programming the Excel sheet to give you a solution. For example, if you use an MRP, so I think this,
exactly.
Yes.
But again, if you don't know, for instance, for forecasting, now Excel had real statistics. I use it in my courses, or I use in R, for instance, as well in my courses, which is free. Okay. Again, it's like it is free, but if you don't invest on someone to teach the majority of people there for this, then we are blind. We are blind. We are totally blind. So I could implement whatever kind of forecasting methods, for instance, which is forecasting is an important action in the age of Industry 4.0 to optimize whatever thing, because this is a starting point for many of the decisions. So you could develop in Excel or in R, which is free. But again, if you don't know the algorithm, if you don't have someone to teach you the algorithm at the school, and then later also someone to connect, to make you connect the algorithm, not hand calculations, just the algorithm with at least an accessible technology, then we are blind. We're totally blind. So we don't need this, for instance, sometimes I teach my students multi-criteria decision making to optimize conflicting objective. I want to optimize my network, to optimize the transportation cost, but the responsiveness as well. And I showed these students, you know, free platforms to do that. Of course, something what is free require more effort in the way of understand the algorithm behind, you know, but it's a solution. And then what you invest in a software like SAP, which is, I don't know, extremely expensive. Nobody can explain. But SAP, the basement of SAP, because I know that, especially in Germany, I know that the basement of that song, there are algorithms about inventory optimization. There are models, optimization models, and algorithms to solve that. Why not to teach that using Excel? That's the idea.
Great, great, Professor. I think I can see very many comments. People have enjoyed the webinar. I think we need to focus on the mathematics. Supply chain is all about mathematics, all about parts moving, optimizing those parts is the best decisions. So we are going to close the webinar here. We will share the link once we get the video with the participants. We thank you very much for participating. You are very active. Be on the lookout for our next webinar next week, Thursday, the same time. Also check out Professor Yassel on LinkedIn, connect with him, connect with Beatrice. With Zaragoza Logistics Center, we take people annually, once or twice a year, to the center from Africa. Of course, with COVID-19, we are waiting to see. We had scheduled for October 28th this year. We will communicate on, depending on what the governments around the world tell us and what is possible to, when travel will be ready, please join us to go to Zaragoza. I see Mohammed asking what is the full name of the professor. Mohammed, I have your number. I will send you the profile link on LinkedIn.
Yeah, you can Google my name. That's it. It's you got, I like LinkedIn, School of Google, ResearchGate, all this stuff.
Thank you very much. Thank you, Professor. Thank you, Beatrice. I know Rosa to jump out. Thank you, everyone who has participated. Have a good evening. See you next week, and God bless you all.
God bless you all too. Thank you.
Thank
Bye-bye.
you. Bye now.
Bye.